Welcome to the iView Open Systems Technical Training Series. Today we will be looking at IP and MSTP networks and special considerations when putting open controllers on third-party systems. We will cover MSTP networks as part of open systems, TCP considerations when putting open controllers on third-party systems. To start, we will look at the MSTP network. The MSTP network is a master-slave token passing network, and thereby derived the name MS for master-slave, TP for token passing. The devices on an MSTP network can be either masters or slaves. Masters are defined as controllers that can initiate communication and they will respond to broadcasts, while slaves only respond to direct requests for information. iView open controllers are all considered master devices. On any given MSTP bus, each MSTP device must have a unique address on that MSTP network, and that address is commonly referred to as a MAC address. For master devices, that MAC address can be in the range of 0 to 127. Slave devices, on the other hand, can have a MAC address in the range of 0 to 254. When you're using iView Open devices, the MAC address is set using the rotary switches which are on the open controllers and also on the routers. The MAC setting for these rotary switches is 99. Thus, the highest MAC address that you can assign to an open controller is 99. On MSTP networks, in order for a device to initiate communication, it must have that token, which is being passed across the network. The way the open system works is that on power-up or following a collision, the lowest addressed device creates the token and starts passing it. This is ensured using a routine internal to the controllers where they power up and look at the MAC address that they're assigned and power up with a delay based upon their MAC address, thus ensuring that the lowest addressed device is the one that creates the token. Master devices passes the tokens from one master to another and uses that token to gain information. When it's done, it will pass it on to the next master. There is a setting in the MSTP network called the max info frames, and this setting determines how many requests for information a given device can make before it has to pass the token on to the next master in the list. To determine the next master recipient, a master device will do something called poll for master. What that is every 50 times the controller gets the token in an open system, he will initiate a poll for master where he checks the addresses between himself and the next master in the list to see if there's a new master that has come on the bus since the last time he checked. And if there is, he will add that information and will then pass the token to that new master. When an open controller initiates this poll for master, it will just poll one address per time he gets the token. This poll for master is only going to occur if there are gaps in the addressing scheme of your system. So if you have controllers with address say 5, then 10, and then 15, and then 20, as a result of having that gap in between those controllers, there will be poll for masters initiated. However, if those 4 controllers are addressed 5, 6, 7, 8, then controllers 5, 6, and 7 would not have to initiate poll for masters because the master that they're passing the token to is already the next consecutive address. However, controller 8 would be doing poll for masters every 50 times that he gets the token to determine whether or not a new controller has been put on the bus between that address 8 and what he has in his list as the next master, which would be address 4 or address 5 based upon the example. If we look at a simple iView open system, here we have a RTU controller at address 2, a VVT zone address 9, a bypass at 14, and another zone at 15. And as we see here, we have gaps in between these devices, but the addressing between the bypass and the second zone, there is no gap. If we look at bus information using backscope in this example, we can see the token being passed between the 4 controllers. So here, looking at the backscope capture, we see address 2 passing it to address 9, address 9 passing it to address 15, and address 15 passing it to address 16, and then the next master after 16 is going back to address 2, so they're going back and passing it along. In this case, since there is no information out here in the data portion of the backscope, the controllers are not actually asking for any data when they have the token, so they're immediately passing it on to the next master in the list. Since there were gaps in the addressing in the example we showed, we will also see periodic polls for master, and we can identify these in the backscope capture. If we look here at message 2074, we will see that controller 2 is polling controller 3. Typically he's passing the token from 2 to 9 as we saw in the earlier scan. In this case he's going to 3, and if we look in the details of this message, we can see that he is indeed doing a poll for master. And as we indicated earlier, he does one address each time once he starts this, so it's fair to assume that it's been 50 times since the last time he did a poll for master, so now he's got the token for the 50th time, so he says, okay, it's time to do this poll for master, but he only does one address at a time once he started initiating it. So here he does 3, then he has to pass the token on to the next master. Once he gets it back again, now he's polling address 4 for poll for master, and then next time he's going to do 5, and so on and so forth until he reaches address 9 again, in which case he's saying, okay, there's no new device in between myself and address 9, so I will just continue passing the token to address 9 until I've passed it 50 more times, and then I'll do another poll for master. Any questions? Now we shall look at the TCP/IP network. Open routers and open links are BACnet IP to MSTP routers, so they're taking messages either from the IP side and routing them to the MSTP side, or messages that come from the MSTP side and routing them out onto the IP network, whether it's to get to a device that's on the IP network, or if there's another router, open router out there that has an MSTP network on it, it may be routing it out to the IP network in order to get it to that other IP to MSTP router to talk to an MSTP device under another router. The internal router of an iView Open server is also a router when the USB adapter is used. When you add open routers and open links, it allows you to access IP open devices from the IP side in addition to just accessing them through the RNet port or the local access port of the controller. It also allows you to expand systems beyond the 60 device limit of an MSTP network running at 76.8. Open routers have both an IP address and a MAC address. Since they're routers between the IP network and the MSTP, they have to have identifiers for the IP network, which is the IP address, and for the MSTP network, which is their MAC address. The MAC address of of an open router will always be 0 on the MSTP side, and this cannot be changed. When you have a system with multiple IV open routers that does not have a front end, one open router should have the rotary switches set to 0, 1, and this makes him the master router. The master router in an open system will serve as a time sync master for any other open routers that are part of the system, and will also collect color status, which has to do with your temperature statuses for your various zones or your equipment from the other routers as a central depository in that 0-1 router. And this, by having this all in one spot, allows quick access to this information if there were an IV open router. I'm sorry, no IV open server on the system. In looking at an IP setup, we have the high end, we have a third-party IP router, if you will, but we have the BACnet IP network here. We have the IV open server, which could be either a standard or plus that has the USB open router on it that creates this network underneath the server. And here we have two devices at address 3 and 7. We then have an IV open router also on the network. He also has two devices under him, 3 and 7, and an open link at 3 and 7. Since these networks, these MSTP networks are all unique, the fact that the MAC addresses are identical is of no consequence because they are separated from each other using these MSTP to IP routers. When you have IP networks, you potentially need to have what are called BBMDs or BACnet broadcast management devices. In the BACnet world, a lot of communication is done via broadcasts. For example, discoveries are all done using broadcasts. And when you have IP networks, you typically will have devices that are sitting under different routers on the networks. And the routers themselves, they don't pass general broadcasts through them. So BACnet had to come up with a way of managing the broadcasts to get them across routers, and this is done using the BBMDs. When you're using BBMDs, you only need to have one BBMD master per subnet, and this will typically be a router. And to set up the BBMDs, you use the BBMD configuration tool to enter the applicable data into the routers on these different subnets. If you have an IV open server with an internal router, then you can set the BBMD on that internal router. However, if the IV open server does not have an internal router and it just is using the 127.0.0.1 address, then you cannot use the BBMD config tool to set BBMD of the server. If you've got IV open routers and links on different subnets, you must first set up the BBMDs in order for iView or Field Assistant to be able to fully discover the entire system, because, as mentioned, BACnet uses broadcast to discover controllers, and if you don't have the BBMDs configured at the time you're trying to do the discovery, then the broadcasts that Field Assistant or iView is sending out will get lost in the routers, the network routers, because they won't be pushed across because the BBMDs haven't been configured. So in looking at BBMDs, if we have a network similar to this where we have the iView open server on an IP network with an address of 141.6192.87 with a 255.255.255.0 subnet mask, and this has the USB open dongle on it, so we have an MSTP network underneath that open server, and then we have another network router with an open router underneath it. In this case, the IP address is 16.128.12.22, and we have an iView link under a third network router at 41.422.54. These three devices are all on different subnets. We know that by looking at the IP address and the fact that the subnet mask tells us that the IP networks are all different. So to set up, we would need to set up BBMDs in each one of these in order to ensure that they can all get broadcasts from each other. So we would need to set up the BBMD table, and using the BBMD configuration tool. So what you would do is you would create a text file with loading the IP network IPs. So the file itself would contain each one of those three IP networks, because if we look back here, there's only one open device on each one of these networks. If we had a second link, for example, that maybe had an IP address of 41.422.200, that link would be on the same subnet as this one, because the only digits that's changed would be that last octet. So only one of those two links would have to be in the BBMD table. So going back and looking at the table, we have each one of these three IP addresses, and this data would then be downloaded into each one of the three open devices, the open server's internal router, the open router, and the open link, and thus they would be able to communicate broadcasts between each other and on their subnets. Looking at addressing of open controllers. An iView Open Controller has two addresses. It has its MSTP network address, and then it has its BACnet system address. And this is true of any BACnet device that's sitting on a MSTP network, not just open controllers. For open controllers, the BACnet MSTP network address is set using the rotary switches that reside on every open controller. This address must be unique only to the local MSTP network where that controller resides. And this MSTP network address is typically referred to as the MAC address of that controller. In looking at our network here again, we see we've got similar addresses on different networks, but because they are on separate MSTP networks, the fact that the MAC addresses are identical does not cause any type of conflict as part of the communication of these controllers, because the MAC address is really only used for communication on that local MSTP network. It's not what's used to communicate between controllers directly. The BACnet system address, which is often referred to as the device ID or the device instance, and that's used on the system basis as opposed to just on the MSTP network. For open controllers, this device instance or device ID is generated automatically, but can also be overridden and given a manual address. When it's generated automatically, it is generated as a combination of the network number that the controller resides on and the MAC address. If you choose to set it manually, you would need to do it through software using BACview, Field Assistant, or iView, and you can set it to any valid BACnet device ID, which is the range of 1 to 4 million and some, 128,000 and some number. By default, controllers have their rotary switches set to 0. So both rotary switches are set to 0. In this configuration, the controllers will not communicate on the MSTP network. So as part of commissioning controllers, one of the things that needs to be done is to change the rotary switch settings to be a unique setting for that MSTP network. The default baud rate is always 76.8, and that typically should not need to be changed. By default, the controllers will have a network number configured internal to them, and this network number will be 16101. So without a router on the network, they will still have a default network number of 16101. Since the device instance or the device ID of the controller is automatically generated by default and is a combination of the network number and the device instance, by default there will not be a device instance set in the controllers because the rotary switches are set to 00, which is an invalid address. So it will not be able to generate that device instance. On a router, the router also defaults to rotary switch address of 00. The dip switch is set the baud rate to 76.8, and it has a default IP address of 192.168.168.1. By default, the IP network number of an iView open router will be 1600. And while the MSTP network number will not be set, nor will the device instance, because both of these are dependent upon the rotary switch settings. Looking at the auto-generating scheme that's used with open routers and controllers, if you have standalone controllers or systems that do not have an open router, they will always have a default MSTP network number of 16101. So the controllers themselves out of the factory always have a network number of 16101 by default. That network number will only get updated when the controllers are connected to an open router, and then it will change based upon what the MSTP network number is of that router. If we look at how these addresses are generated automatically, if we look at an open router or link, the IP network number by default is 1600. The device instance of the router or link is 1600 plus the rotary switch settings, which are 00 by default when they need to be changed from 00. So until those rotary switch settings are changed, the open router or link will not have a valid device instance. The MSTP network is also set based upon the rotary switch settings, and it will be set to the rotary switch settings, and that is appended to 161. The one way to look at this is the 16 is derived from carrier's vendor ID, BACnet vendor ID. Every manufacturer of BACnet equipment has their own vendor ID. Carrier's is 16, and that's what we're using to generate these numbers. It's not something that's set in stone. It's not necessarily a standard. It's a common practice across the BACnet community, but is not a requirement. The MAC address of an open router or link, as we mentioned earlier, is always 0 and cannot be changed. One thing to note is the USB adapter network number will be randomly generated when it's connected to the open server, so it will not follow this criteria because there are no rotary switches on the USB adapter, so there's no way for it to pick up that information. In looking at iView Open Controllers, their device instance is generated from 161, which is, if you look at this, is 16 is the vendor ID, and 1 is an indication that it's an MSTP device. So it's vendor ID, MSTP device, the rotary switches of the router, plus the rotary switches of the controller. And this would be true when it's connected to a router. As we indicated, by default, the controllers will have a network number of 16101, so it's assumed that they'll have the rotary switch settings of the router are 01 by default as far as factory shipped controllers. The MSTP MAC address of the open controllers is set from the rotary switches of the controller itself. And as we indicated, the MSTP network number residing in the controllers is 16101 or whatever it learned from the router that it's connected to. Looking at router setup and the IP addressing, routers or links can be set to an assigned IP address, or they can gain automatically the IP address from a DHCP server residing on the network. If you are looking to assign an IP address, you can use BACview to do it. If you decide to use hyperterminal and a PC, then what you would need to do is set dip switch 1 and 2 on the router or link, cycle to power, because the router and link only read those dip switches when it's powered on, connect to the router or link with a PC running the hyperterminal using the USB link cable, or connect through the S2 port, which is the serial port on the router and link. You then run hyperterminal and you will see a menu such as this, and you'll see here you can hit 3 to set the IP address, 4 to set the subnet mask, and 5 to configure the default gateway. You'd also have access to the BACnet IP network, which defaults to 1600, and there should be no reason to change that. The BACnet UDP port is the port that BACnet uses by default. It's BACO, the hex is 47808 in decimal, and you should not need to change that in typical installations. When you have auto generation with the external routers, as we indicated, the controllers pick up the network number from the router. So if we have an open router on the network where the rotary switch is set to 1 or 01, that, as we mentioned earlier, will create a device instance for that router of 160001, because it takes the 1600 plus it adds the rotary switch to it. The rotary switch also sets the MSTP network, which was 161 plus the rotary switch, so that's 16101. And then the devices generate their device instance from their network number plus the rotary switch setting, which in this case the network number is 16101. The rotary switch for this controller is 03, so it's 1610103. And for this device 1610107, since it has a MAC address or rotary switch setting of 7. When you have the open server, the server itself has a device instance of 169.999 by default. As we indicated, the MSTP network number using the USB adapter is auto-generated, so it could be something like 16593, this will be communicated to these controllers. So instead of the 16101 network number that we saw in the previous slide, in this case they have 16593, and add their MAC address or rotary switch setting to that network number to get their device instance. If we look at a larger network now with 2 or more routers, we can see that as a result of this addressing scheme, the controllers that reside underneath the server, which has the network MSTP network number 16593, now have device instances of 1659303 and 1659307, whereas the devices or controllers that reside underneath the router that has the rotary switches set to 01 have device instances of 1610103 and 1610107 respectively, which means that they are unique, and it is imperative on BACnet networks that the device instances of all controllers on the BACnet system is unique, and through the auto generation of an addressing feature of the open system, we have ensured that these device instances of the controllers are indeed unique, even though their rotary switch settings or MAC addresses are identical. If you want to do manual addressing of the routers, you can have access to this in either Field Assistant or in iView. If you after discovering the routers, if you go into the Advanced tab, you will see that the routers all show up, and if you uncheck the auto column for a given router, that will then give you access to the device instance or device identifier and allow you to enter in a manual device identifier. You should do this with caution because of the auto addressing and the chance of having duplicate either device instances or having controllers with duplicate device IDs as a result of doing this. So this should be done with caution. You can do the same manually override with controllers. After uploading controllers, going to the Advanced tab, similarly they have the auto column, and you can disable the auto generation and enter in manual device identifiers. This can also be done using back view, if you will, right at the controller. Once again, caution should be taken when doing this, as if you have duplicate device instances on the network, you will have problems. Some advanced information. The maximum number of device instances, like I indicated, is 4 million, and some, in this case, specifically 4,194,302. With our auto addressing scheme, if you end up with network numbers greater than 40,000, you could potentially have errors in the auto generation system because you'll end up with device instances greater than that maximum device instance of 4,194,302. So iView will automatically subtract 40,000 in these instances. So what you'll have, if you have a network number in excess of 40,000, so say in this case 50,000, what it's going to do is it's going to subtract 40,000 from that network address, and that will drop it down to 10,000, and that is the network number that will be supplied to the controllers, and then the controllers will then append their MAC address to that new network number, which will be 10,000. In this case, their device instance turns out to be 1,022, which is below the 4,194,302 device instance limit. When would you do auto addressing versus manual addressing? Well, auto addressing, allows you to automatically have the routers configured, the links configured, and ensures a unique network number on the overall open system. Manual addressing will give you potentially give you unique network numbers in cases where potentially the customer, or if you are adding routers to as part of a third-party system where they're telling you need to do it, then it allows you to create that. And when you're doing that, you can also do the manual process for the controllers. It is our recommendation that using the manual addressing only be done as an exception, not the norm, because, like we indicated, it can cause greater problems both with networks in general and with communication. Some considerations if you should happen to have multiple iViews servers on the same system, or multiple iView systems on the same LAN. As indicated as part of the BACnet standard, a network must have unique device IDs, and all the MSTP networks must be unique. In fact, all the networks must be unique. In BACnet, you can have up to 65,534 different network numbers. By default, if you've got an iView Open server, it will have a device ID of 169.999. If you place two or more iView Open servers on a given network, now whether that's in a given building or if you have a customer who has their own LAN, for example, United Technologies, if you have two or more campuses that are part of the UTC company, even though they're different buildings or different cities, they'd still probably be on the same overall corporate LAN, and thus you must ensure that the device instances are still unique. And given the fact that every iView Open system is going to use the same auto addressing scheme, if you have two or more systems on the same overall corporate LAN, then you will need to take that into consideration when doing the addressing of your routers and also the addressing of the servers. One of the problems that you can run into is if you have two or more servers on the same LAN that can be found by BACnet. A common problem that results from this is that alarm data and trend data may be permanently or periodically lost because trend data and alarm data is sent to the server, and it's done based upon the device ID. And if you happen to have two servers on there with the same device ID, in this case 169.999, the last one to communicate to the controller or the router will be the one that gets the trend data and the alarm data, and this will result in lost alarms and lost trend data. Some special considerations when applying open controllers on third-party systems. The default network number. All open controllers, like we said, have a default network number of 16101. Thus, it is imperative that the BMS system that the controllers are installed upon does not have their own network, be it an MSTP network or any other BACnet network, with a network number of 16101. If the customer says that you must change it, the only way that you can change that network number would be to connect the controller to an open router that is configured with a unique or whatever the desired network number is. So if the customer or the third-party BMS says, Carrier, your controllers must reside on network 30,010 because we already have a network number 16101, then you would have to configure up an open router with 30,010 as the network number and connect the controllers to that router over the MSTP network and allow them to pick up the network number that will be broadcast to them from that router. Typically, third-party routers will not send the MSTP network number to open controllers. The exception to that is other ALC or ALC OEM customers who use a similar router to what we have. Those will also send their network number, and that will be accepted and processed by open controllers. But if you're using an Allerton, or if you've got controllers that reside under an Allerton MSTP router or a Symmetrix or Contemporary Controls MSTP router, the router will not send the MSTP network number to the open controllers. And as we said, open controllers use the network number to generate their unique device ID. So if you have more than 2 or more controllers under third-party MSTP routers, then you will need to consider doing manual configuration of the device instance using BACview or Field Assistant, because you may have controllers with the same MAC address under 2 or more third-party routers, and they will then both have 16101 as their default MSTP network number, and if their rotary switch MAC address is the same, then they will have duplicate device instances. So the only way to avoid that in that case would be to use BACview or Field Assistant to set the device instance manually for those controllers to ensure unique device instances. That concludes this presentation. Thank you for your time.